Welcome. I told the early people to expect kind of this forced march of fun because that's kind of how it will be. What I'm asking for you all is we're going to be covering a lot of ground with a lot of different technologies. And with a technology workshop, there's usually a lot of unhappy people. Because either you're here for like a nuts and bolts thing, like I want to know what do I click when I want to do this. Or there's a bunch of people who are interested in like big picture pieces. And invariably what happens is neither one of those is met and you leave being like, that was a waste of my time. The goal of this one is a more overarching one. But what we're going to be doing is you're going to be working in groups. And this will also help to mediate some of the issues. So what I'm asking for you is a little bit of flexibility. So like if you run into an issue, you might be like, oh my gosh, this is moving too slow. I'm dropping my computer and then I'm going to join this person with their experience, okay? So we're gonna hopefully have a little bit of flexibility. Feel free to stop me. This isn't just a one-way delivery. You should feel free that you can stop and ask questions. But I might put that in the parking garage and we can come back to it, or I can email you and help you with that issue at another point, okay? All right, are you all ready? Are you a little nervous inside because of the expectations? Well, you can join me in that. So the idea kind of originated in, we have all these free technologies on campus, and the idea is we don't really necessarily promote how we use them. And so the original goal of this workshop was to try to figure out how we can better leverage what we have available and kind of create a community of practice around that. My two objectives for this workshop are, one, that you'll have a few new strategies and tools for teaching science practices. You may not get the whole suite, but hopefully you'll latch on to a couple that are resonating with where you currently are at. And that we continue to build our community for methods and expertise in teaching science practices with this tool. So the idea is, like, when I say like you're in a group, you should really be like, hi, what's your name and what's your email address, right? Because I might be in contact with you later. You can also feel free to contact me at any time. That's part of my job, is to help support you all in this endeavor. Today we are joined by two people from IT services. So we have Mohit and Raghu. I'd like to say I'm an expert in everything that I'm going to be talking to you about, but I'm totally not. And so that's also a little bit of anxiety, because I think I've used some of these tools in some of these ways, but in order to give you the kind of comprehensive picture that we're going to do, there's been a little bit of new skills developed in the last few weeks. So we can hopefully draw on our experts here, and they may also not know the answer because we haven't had a long history with using these tools on campus. All right, so with those very low expectations, let's get started. Okay, so the way that we're going to go through this, I'm going to give you a quick overview, and then the majority of this workshop is actually going to have you play the role of a student doing a science practice. So we're going to go through mini science practices, maybe, I don't know, 8 or so. So you'll get at least a touch in, and this is the other thing. It will pain you to write a question, a scientific question, where it may be grammatically incorrect and you might just be putting it together in a minute. It's okay. It's going to be a very low judgment zone here, okay? So be willing to toss out low quality work, because we're going to use that to bounce off of. But we will be looking at Forms, Excel, and OneNote. And then hopefully at the end we're going to have some time for discussion about what worked and what didn't. Okay, so the basic roles of all of these technologies are basically in generating content, organizing materials, and then delivering those materials. And by the way, these slides are all available for you in the OneNote notebook that you'll be exploring today. So the thing is, we might be trying a tool in here, and you might be like, yeah, I can actually do that, and I can do that better using Python. Or I can definitely do it, but I use Keynote instead. This is not arguing that there are better programs out there. What we're kind of focused on is this idea that there are advantages leveraging this tool suite. Specifically, it's free for all students and instructors. So the idea is that there is no cost burden for your students, and you can have an expectation that all of these programs will work on their computers, right? So this alone is very big, right? So reducing the cost barrier and making sure that all students have the available software. It also can lower the cognitive load, so the amount of processing that they have to do in order to learn a science practice, in that most of them have experienced Microsoft products before, and also it potentially prepares them, and there's also this compatibility among their programs. Yes, there are times when they are not compatible and it's very irritating. But for the majority, the similar types of fast, like hotkeys or approaches that you might use are translatable, right? So again, this reduces the amount of mental space they have to use in order to navigate the software as opposed to learning the content. It's also likely a professional skill that they can then leverage in their future careers. Regardless of how you think about Microsoft, it is fairly ubiquitous. And they're also, being a large company, they're held to accessibility standards that other companies may not. And so in many ways, you will be more accessible by using these materials than using third-party software that is maybe a smaller company. So all of these are going to reasons why you might adopt the entire suite in order to promote student interaction. Okay, so what science practices are we talking about? So I rooted it kind of in two main frameworks. There's this NGSS, which is the Next Generation Science Standards, and the framework, which is mostly K-12. These are K-12 systems for thinking about science practices. So things like asking questions, developing and using models, carrying out investigations, analyzing and interpreting data. All of these should resonate at some point. And the one thing I do like about referencing these is that you may have a science practice that you're really invested in, like analyzing, interpreting data. Sometimes it's hard to know what skills that makes up. And the interesting thing about going to the NGSS is that it actually breaks them down based on grade level. And so you can kind of get a better sense of, if you were to scaffold that skill, what things would you need to put in place that would allow them to then progress further. But also we looked at vision and change, which is looking at changing the biological curriculum around science practices, which had very similar, again, skill sets that they were trying to train. So these two systems were kind of referenced in the development of this workshop, and there's some references in your OneNote notebook that you will also find to reference. Because the 3D lab, which many people on campus, Becky Matz, Melanie Cooper were involved in the development, and Corey Fada-Hartley. And I'm sure actually probably half this room that I just totally dissed you on that, and I apologize. But it is a very popular method for thinking about assessment, and it's rooted in at least the NGSS and the framework. Okay. The other thing to think about is that when we talk about a science practice, we're going to go through these at a breakneck speed, and you're going to be like, that wasn't a very good treatment of how to ask a question. Granted, because actually if you take any one of these skills, it actually takes a while to build up to how do you use that skill, right? And in some ways, you may only focus on one skill in your classroom. It's not like you're going to be focusing on the entire science, the practices that involved in the entire scientific method, right? And so even if you think about one skill, it also cascades to being more complex. So even if you look at modeling, you may focus on visual models in your classroom, but that doesn't necessarily prepare students for mathematical or physical models, right? So these are very robust pieces. And what it entails is also thinking about, if you use the same software suite in your class, you may be able to coordinate across your curriculum if you have a very welcoming faculty group of where you can actually scaffold which skills you're covering at what point in your curriculum. Okay, so I know how many of you teach very large courses? Okay, so the way that we're going to be presenting these is thinking about methods that allow you to incorporate these in large scale courses, but they can also scale down to small courses if you're interested in. And so we'll be focusing on these types of getting group feedback. So peer review using rubrics, unpacking in class. We actually won't run a fishbowl, but I'll leave references for how you do that in the OneNote. And then looking at group work. And then we'll have one case where I'll actually break down and look at individual work, knowing that there's no judgment about what you actually produce, all right? And then why we do group feedback. So group feedback in general has about a 0.8 effective size when you look at the research literature, which is very high. So of all the things that you can do, who knew giving feedback is actually effective? Research tells us that it is. And so if you use group, it allows, in group feedback, it allows you to provide it faster, less work on you, promotes cooperative learning, and it's also a fail-safe for these things that we're going to be doing. So all of a sudden, someone's like, oh, I didn't bring my computer to class. That's okay, you have 2 other group members who can back you up. Oh, I don't necessarily know what I'm doing. That's okay, you have a peer that can help you catch up to speed. So these are kind of the methods that we'll be focusing on this workshop. Okay, that was the spiel. Now we're gonna kind of tour through your experience in your OneNote notebook. Any questions before I move on? All right. Okay, so the one thing, using a OneNote Classroom. So this isn't just a straight OneNote notebook. They're very similar, but there are some tools in this that you can use in order to manage your classroom. So in general, what you should see on your computer are the top 2. You should see the welcome, the collaborative space, the content library, and then your own personal notebook. Right, and so if we unlock one's notebook, sorry Rachel, we're putting you on display here, you can see that you should have this tab structure. Okay, so the welcome I didn't mess with. It has a bunch of tutorials for helping you think about OneNote and how you might use it. The collaborative space is actually like a wiki. So the idea is that any student can participate in leaving materials here. And so as a group, you can construct pieces of curriculum, which we'll do in just a second. The second piece is the content library. This is like a unidirectional piece. Handouts and things like that that you all can copy and paste into your notebooks, but you can't modify. All right, so this is just a one-way directional piece. And then you have your own personal notebook. So the way we're going to be running through this is that you're going to go to your handouts section. And let's go ahead and start getting into groups. So turn to your neighbor. Even ones you don't know. Hi, my name is. Hi, my name is. Take a few seconds. Okay, enough. What do you think this is? Some kind of lounge? Focus, people. If you haven't gone yet, you should. Is everyone at their OneNote notebook? Okay. All right, good. Kendra, I've added you. Yeah. Okay, so I have no idea how I am on time. All right, so as a group, your first challenge, and you don't actually have a choice to accept it, you have to, is click on the scooter project. So your first challenge is to go through tasks 1 through 5. So we're actually going to try to do a research project around scooters on campus. Okay? So through 5, so that will take you through 1, 2, 3, which is about finding your background research. And then you will go to forms, which is that second page, to do tasks 4 and 5, which is what you're going to do is you're going to peruse this article on scooters. You're going to develop a question you might have about scooters by going to Google Scholar and finding some articles, posting them in our shared space, right? And then you're going to develop a question you have that you would like to collect data on, and then you're going to enter that question into a Google form so that we can all use our mobile devices to actually take a survey. Seems like a lot. Take a deep breath. If for any of these things, if you notice up here in the handout section is a how-to guide. So all of a sudden you're like, I don't know how to. It has a breakdown for each task. So if you don't know how to do task 1, go look up the OneNote guide for students, task 1, 2, 3. Then it jumps in tasks, so you'll have to go down to forms for 4 and 5. Just so you know, these aren't Google Docs, which means, like, you know, in Google Docs when you're simultaneously editing and, oh, I can see who's doing what. That's not what this is. So you'll have this weird delay, and then all of a sudden things will appear, and then you're like, I don't know where that came from. And just keep that in mind. We'll come back to that point in a bit. Even if you did not get through, how many got to task 5? You had to move on to the next. It was to the form piece. Tasks 1 through 5. I should have put it on the board. Lesson learned. Next one, I will totally do this. That's okay. So on task 4 and 5 was creating a question in Google Forms. The question about deleting. We'll come back to this. Okay. So how you were able to name a tab in your notebook called questions? Okay. So I'm going to show you one of the features of a Google Classroom notebook, which is first off, I can access all those materials. But when you have 100 people and they all have multiple documents, it can be a little challenging. So we're going to review student work. I'm going to sign into this notebook. Is
so should we be able to see that menu, like the file menu?
Well, you should not be able to see these.
No, but just the top menu where you're pulling down past notebook and stuff. Yeah.
Oh, this?
Yeah, just the task.
No, that's the instructor piece. You all are students right now. No, yeah. Students forget their place. No. It was under lab recordings, right? Okay, so I just clicked that section. Little churn. And then I can do questions. And now I can look at Corey Feta Hartley's question. Right? And so it's a means of actually going through all the notebooks and looking for specific pages that you can then evaluate. You can also, I can lock the pages so that if you are going to evaluate them, they can't then modify them while you're grading them. So this is one of the features. This is like the only thing you'd be talking about if you were doing individual work, because mostly we're group aspects. How does the computer know what? All the permissions are behind the scenes, and so when you create the classroom notebook, you are the instructor. And you can add other instructors as well. Okay, that was that feature. Now we're moving on to actually using the questions that you all created. So now that you had created questions, what I'd like you to do is either on your computer or on your mobile device, go to this website. Let me know if anyone needs me to read that out. You're just a student. Yeah. Yeah. Can you raise your hand when you get there? Okay. Does it actually look like a survey that you could fill out?
Poorly written.
Okay. So we had a comment that it was a poorly written survey. Totally true. And that's actually where we could have been as a classroom discussing research data collection. To pull those questions up and be like, all right, let's look at this one. This one is atrocious. Okay, you wouldn't say that to your students, but this one could use some help. It has a really good STEM, but maybe some of the distractors need help, right? Okay, so what I'd like you to do is to actually pretend that you are out in the field, right? Because students could take this data collection survey to the field to collect real data, right? So not only can they create the questions, but then it's ready to deliver. And so you can go out, people can enter the data on their mobile devices. In this case, you'll do it on your computer. Go ahead, fill it out, submit it. Make up things. I know this is like going against every grain in data. This will be the only time. He said we could make up data. Yeah, I can see the quotes in this. This is the one time you're able to do this. Okay, how many do we have? Does everyone still need more time? More time? Okay. So if we look at the survey, we actually can see our responses in real time. So you could actually use this as a classroom response system because it does update. But then what I want to do is open this up in Excel, and then I want to not do that. I'm going to input a file. No, that's not what I wanted. Sorry about that. So as the instructor, I'm now going to input your file here. Okay. So within relatively few minutes, we were able to create a survey, collect the data, and now you actually have the summation of the data. You could actually open this up. You could have gone to the, I could have just sent you back to the collaborative link, and you all could have downloaded the Excel data as well. But you may not want to give that power to students. You may just want to present the data to them. So now you have this, the data for your next part. You have 12 minutes for. Your tasks are going to include, you're going to make a graph from awesome data that we have. You're going to paste it into a page, and I'll tell you which page. You're going to download an Excel simulation, which is this task 8. We have a sample of some simulation that's been created. Okay. You're going to copy a handout into your notebook. That's a minor one. Here's the big one. You're going to draw a model of your system or the mechanism that you think is going on. A physical model. You can either do it in the OneNote notebook, or you can draw it on paper and take a picture and then post it into your OneNote notebook. Okay? 12 minutes for 6 through 10. If you did not get your visual uploaded, that's okay. How many did we have upload? Visuals? Okay. Well, I guess we can look. So we'll go into our collaboration space. Shared space. Okay, let's go through like some of the pieces that you all were able to construct, right? So very quickly, if we look at the resources that were available, I know we have a warning. Right, so one was a group able to construct a database of very important references, right? The other piece, there's also training for helping people to understand how do you move forward and backward in the literature, right? So if you're talking about information literacy, that's part of science practices. This is where you could also reinforce that. Our graphs. So what we might do is, as a large group, I might be like, oh, these are awesome graphs, but you know, labeling axes is very important, and this is something that we should all be doing, right? So this is basically unpacking one example in order to impact other people. So you could say axes are very important, and on your next, on your official evaluation assessment, if you don't do that, you'll be counted off on that, right? So even though it's not individualized feedback, I'm not saying yes, right? But in general, you're talking, right? It's a way of giving feedback and still having impact. Okay, visual models. Yes! I'm not going to say that this is brilliant. This gets at also some of the things when we talk about, like, if you report on it, right? So you could have, okay, group 4, whoever this was, walk us through your process in this, right? And then so we can have a discussion around a visual without all of the time it takes in order for them to come up, to put on the overhead, the added stress of being in front of the entire audience, right? These are all ways of, you know, again, how you might use the teaching of science practices. And it's also very difficult to do things like visual modeling sometimes in a classroom that then is digitized. And in this case, people could use their phones to take a picture and email it and then drop it into their notebooks. It's a way of collecting data. So even if you're in the lab, they could take pictures of results, and that's a quick So these are all ways that you could use this aspect of drawing and capturing it in a digital form. Just to look at some of the other awesomeness that went on.
So if you did want to go, like, group by group and report out here, you know, how are these actually organized in labels? Really, you have to have some put their name on it or something?
That's right. That's right. And all of these actually have like a best practice. What I'm showing you is not best practice. First off, you might try only one of these in your classroom, not 20, right? The other thing is figuring out what are these barriers that, and then how do you create structures around that. So if you noticed in the first piece where you all were putting down the literature, there was like a suggested template where it had your group name, then the original article, the new article, and the old article, right? So you can create templates that people do. You might also have a page that's dedicated to each group, right? So here, instead of having group resources of interest, graphs, I could say group 1, group 2, group 3, and then all of the materials that they're presenting out would be there that we could just easily navigate to, right? So you should not view this as this is how you do this. This is just giving you like lots of ideas of which you can be like, oh, I could take that and make that so much better, right? Yes?
Actually, if you could please use the mic.
Sorry.
Oh. So I don't know, this have been suggested okay.
Yeah.
before. So the D2L actually does a lot of things you are currently
right.
describing. So maybe you said something in the beginning I missed.
No, totally. This is also looking at, some of these things don't work as well as Google Docs. So if you are all working simultaneously on a document, Google Docs is much easier to see like where people are, what they're contributing, and figuring out where you should be placing text. This is definitely more willy-nilly, and so you may not, as a group, at the same time construct a document. You might be like, over for homework, or over the next week, insert things, and that would help to alleviate that piece. But what that gets at is there are lots of different segmentations that you could use with D2L, and the question is thinking about your environment that you're creating. So are you going to ask them to do D2L and then do versions of Google Docs and versions of Microsoft Word? That would be a lot of different technologies that they're trying to navigate that increases their workload. And so this is basically just trying to show you, just using one suite of software, how you might scaffold the science practices. You could totally take very similar things and put it into D2L, or you do similar things and do it with Google Docs. Totally do that. But figuring out which tool set you use and why is kind of important. And one of the reasons why I chose this one specifically is because of Onenote, because I've used this in, I teach a K-12 class, not K-12, it's K-12 teachers. It's like one of their last science classes. And the idea is that this really simulates a lab notebook and allows them to reflect and do reflections and capture data. And then also when they turn those in for grades, I'm not carrying 30 notebooks around. I actually just have a list of links and I go to their notebook and I review the materials. And so it has different affordances. And so figuring out which one works for you is great, but just understanding that the more technologies you add, the more you are putting in hurdles for students. Okay, so all right, ready for your next tasks? This is your last group. So it's tasks 11 and 12. So basically in this task, you will be reporting out. So you will be creating an online PowerPoint. So you'll be using PowerPoint online, not PowerPoint on your computer. And then you're going to share the link to that PowerPoint using the Google form. Okay? Does that make sense? There's directions in there too that actually spell it out in more detail. So check those out. And if you have questions. This one, you're going to have 10 minutes. Looks like everyone has relatively got their slide of awesomeness loaded and ready. I was going to make you eat and present your slide of research, but instead I'm going to actually try giving your talk for you. So, the one piece I wanted to show you about this was not this. Okay. Things that's difficult usually if you're going to do group presentations is like, oh, I'm going to bring out my stick and then put it on the computer and then I'll present out. And there's lots of steps involved in that. And again, the form to collect all the responses. I should be able to now go through Shana's and Becky's presentation. Yay, it worked. Okay. So what I'd like you to do is to now call up at the bottom of this page, which is the PowerPoint communication phase, there is a link. Click on that. And then now have a survey for my presentation. The rubric for the survey is above it, in case you'd like to know what those values actually mean. Is everybody there? Okay. So you can now feel free to evaluate my timeliness, my efficacy. Today I'd like to talk to you about this research that I did on scooters. Scooters are a hazard to MSU's campus. My main question was, how will the number of accidents involving scooters on campus change opinions about if scooters should be allowed on sidewalks? Okay, you actually shouldn't be listening to this. You should be evaluating me. You're evaluating me. And again, this is another method of how do you get feedback to a large group of students. The idea is that peer feedback may not be high quality, and that's why you add a rubric in, which helps to align and to make sure that they're looking for the things that they should be looking for. It also helps to train them on what they should be doing in their own presentations, right? So, by the way, I will be able to see who gave me what score. I'm not saying there's any repercussions, but so now if I call up I go here. So you can collect all of the feedback, and if you asked a group question, you could sort it by group and then paste it into, give each group their own feedback. Again, you could also give them access to it, but that's, usually you want to have a filter just to make sure that things are not too scarring, right? Give up your ideas of academia, you'll never make it. Right, so we have 19 responses. That's not what I want. Oh, I opened up the wrong one, sorry. Here we go. Right. I will take that. Right? So, again, these are ways of how you can then get students involved in giving feedback and how do you align it and make sure that it's of quality. Okay, so we went through, let's see. We went through finding references, designing data collection, collected data, analyzed data, made a model, and reported out findings. We used OneNote, we used Forms, we used Excel, we used PowerPoint. We didn't have 60 new students, we had roughly like 30 or 40. I don't know if you've ever tried to wrangle technology. It's super like, wait a minute, my computer's not working, I don't get this, and right? So, needless to say, I've been sweating bullets for the last hour and a half, so I kind of know what you will be going through when you do it. But hopefully you'd also be doing it at a much smaller pace. The idea is also there are ways of, how many of you felt like, oh my gosh, if I mess up on this, I am going to be up a creek? No, right, didn't matter. Same for your students. When you introduce these processes, you want to start off with very low stakes. We're going to start off with checking out cotton candy sales. What do they look like online? Collect some data, put it into this sheet. Low stress. As the technology becomes nothing of a barrier, then you could ramp up the stakes to being higher and higher, right? Repetition. Choose the exact same tool and the exact same methods that you're having them do. If they've never done graphing in Excel, start off doing a very simple one and then build up and build up and build up, right? And by the end of the semester, it's a skill like anything else. So don't just jump in, like this and do it, right? So build up to it. An interesting piece was mentioned about time requirements for doing this. So putting this together last week, I was like, what did I do? Because creating the tip sheets, creating the structure, trying to figure out if all the links work. It's not trivial, but that actually does go into your class's experience, right? So you don't have 15 people asking, I don't know how to do something, and you're like, oh, you could just check this tip sheet that I already made up for you, right? So the more that you work ahead of this, the better. And that's also why you would start small, because you can get that put together relatively easy and then build upon that in the next semester. And that's also why having a community doing that is much better, because you can then rely on other people and what their experience has been. Wi-Fi can be an issue. So if you're planning to do things live in a room, make sure that you can call IT services and they can tell you about the Wi-Fi capabilities of the room. What was your experience with doing this? You all were the students in this case. How did it feel, knowing you can say anything? Frustrated? Yes. So navigating the system, yeah. And that also might become easier the more you do like the exact same tasks repeatedly, right? And you'll figure out workarounds. Like Erica had a suggestion of having 2 windows open so that you can navigate in one and still have your instructions up on the other, right? Right, so there are these workarounds that, again, the more people on campus who are using these technologies, the more students will become savvy with that experience. Yeah. Yeah, of course. Yeah. Right, so the question was about Microsoft 365 and what are the intro skill levels of our students. I actually haven't heard if we know that yet. do you all know if there, yes. So we can check and see with Jessica Knott. She runs some of the academic services in IT, and so we can see if anything has been collected, and if not, if that's something that they could start getting a sense for. Good question, though. Other thoughts about your student experience? Because the question is, your student experience actually helps to define how you would implement this in your class, right? And so the more you can kind of mine that experience outwardly, the better you'll be able to craft something that would avoid those feelings of frustration and knowing that some will come automatically with it, right? Other topics? Are there sciences that you actually do in class that we didn't cover here that you wonder how that would actually translate? Yeah. Yeah.
All of us populating the class. Are we linked that we can auto-populate the class?
No, not yet. There are some auto-population methods, but I will actually show you one additional thing. One tool that I had thought about showing you, but I was just like, I can't wrap my head around it enough to like figure it out. Let me unplug this because I don't know how this will actually come up. 1 second. Which is Microsoft Teams. Has anyone used Microsoft Teams yet? Yes, so it's, has anyone used Slack? Okay, so it's, I will equate these two to be similar. So there's a similar, it's Microsoft's version of that. And so here, okay, I apologize. I will get notifications on this. So I actually created a team for us here. And the idea is that you can store files, you can have conversation. So it's like a texting conversation back and forth. So, you know, we can scooters. And then students could go back and forth with, I like scooters, how about you? And here's a cool source I just found about scooters, right? And so it builds more of a community around conversations. And you can also do things like adding a notebook. And so now in one, not only can you have conversations, you can also go to the OneNote notebook for this class and see. Now you have a OneNote built into your Teams aspects. So you have chats around sharing files, also around having a OneNote notebook. It was too much. I was like, because there's lots of implications for this. We're trying to figure out about how do you implement it into a class. So like if you have it in one semester, how do you get students out and into another semester? Do you have to create a new team? Blah, blah, blah. So there's still lots of things we're still trying to figure out with how to implement it. And I would say that, I should say I am not a Microsoft 365 like, yes, you should use this. There are things that are like, that's a nightmare, but I think we need to have the conversation for what's the best way that we can use it. If you are going to use it, you should think about this. Those conversations need to be had. So hopefully you got some good pizza today. You got some good strategies for thinking about how you might use science practices, and some experiences with being a student and wrestling with both technology and the practice. So great having you. Thank you very much.